Alright, hello, long time no see everybody. What is up? Just check here, make sure everything's working right. Looks like it is, we're live, alright. Cool. So yeah, let's see. Welcome back. It's been too long since we've had a stream, so I figure it's late, but you know, not my usual time, but whatever, we'll just do it anyway. So yeah, here we are, and we're gonna work on some AI stuff. Hey, welcome Imsim Cook, welcome back. We are so back. Alright, so yeah, I thought could be a good time to kind of, and this will be valuable for me too, to have a sort of like video log, I guess, of the current AI system. So yeah, if you guys want to see, I think I'll just kind of walk through what we have. Hey, what's up, Wub? Welcome to the stream. Yeah, so I'm thinking we're going to kind of go do a little overview of the way I've got the AI set up, and then from there, we can work on refining the way they set their positions and everything. So yeah, so let's talk about the base guards. Well, first let me show you how they work. Obviously they work in VR. I'm not going to do this in VR, I'm just going to test it out. I really hope you're talking about behavior AI. Oh, don't worry, Wub. No, I would never use AI. Not for anything important. Hey, welcome, Shiloh. Yeah, wow, this is a big turnout. I should stop streaming for a month more often. Then everybody, you know, comes to say hi when we get going again. The timing of this stream's subject matter is perfect. Why is that, Imsim Cook? Did something happen with AI? Alright, so yeah, so we've got a shotgun guy, and we've got pistol guys, and you see they kinda just, you know, hang out. Every now and then they attack, and they shoot these projectiles, which you can dodge. And yeah, so not a whole lot, you know, pretty basic. We gotta work on their timing of things, of course, but I think this is a pretty good foundation. But so what I want to work on is making it so that they kind of, yeah, I don't like this. I don't like how they kind of clump up. I've kind of improved that a little bit already, but yeah, I can think of some better ways to do this. So yeah, I want to basically focus on getting them to spread out and take solid positions. Let me run over here real quick, and I'll show you how they work in some more interesting geometry. Imsim Cook, been dipping my toe in AI for my application prototype, and it's been a bit overwhelming. Well, yes, that's true. So this is definitely the stream for you then. Alright, so we've got this guy here, and yeah, watch what happens if he loses me. If he loses me, he should come around the corner. Well, maybe. Here he comes. Oh, no. Oh yeah, that's one problem. The way I've got their detection set up, they actually identify the spectator pawn as a target, so they kind of can't be observed, right? They're like quantum guards. They can't be observed. So, oh yeah, this guy's not quite working right. They should chase me. Okay, we'll fix all this on stream. All right, so let me show you how this works. Or doesn't work, as the case may be. Alright, so enemy base, Oh yeah, some of this is really jank, by the way. So this is also my little. I'll make some notes to myself on things to improve and fix. All right. Oh boy, where to begin? I guess let me start by, giving an overview of the architecture, like what's responsible for what. And a lot of this is sort of subject to debate, like what should be responsible for what. I've been kind of taking the approach. Oh, this is the drone behavior tree. I don't want that. Okay. So I've been sort of taking the approach that I kind of have. I have the behavior tree sort of be responsible for positioning, like where they go. But as for like what they do, like I don't have any conditions in here for like attack player. I don't really use the behavior tree for that because I kind of want them to always attack the player if they can see him. So I handle that in here in the AI controller. So, and then I also have a difference between like intention and execution. So let me, try to break that down a bit. So the three classes or the three like parts of AI that we kind of have to work with are the actual pawn, so the base class, like actual pawn, the AI controller, and the behavior tree. So basically the way I've been kind of thinking about this is the pawn is sort of responsible for actual implementation. So like when he dies and ragdolls, the pawn's responsible for that. When he takes damage, the pawn's responsible for that. Actually like aiming the weapon, actually playing animations, all that sort of stuff. The pawn is responsible for all of that. By the way, how's my audio sound? I see some red on the meter there. Hopefully that's not too bad with clipping. Okay, but so basically like physical actions, the pawn's responsible for. The AI controller is responsible for things like perception and getting targets. And then the behavior tree is responsible for the really high level, like go here, go there. Okay, so hopefully that makes sense. So I guess let's think about the loop of like what happens from like when he sees you to like firing a shot. So let's see. So basically we've got our AI perception component, which is part of Unreal's, that's part of the base engine. And right now they only have a sight config. You can add hearing and all of that. But so basically the trick is give them sight and set up detect enemies, neutrals, and friendlies. These all have to be ticked because of some like kind of weird engine stuff. So that's kind of a workaround to ticking all of that. There's a really good video that Epic put out that kind of shows the basics of how this stuff works. Okay, so audio remains good as long as I don't speak too loud. Alright, I'll try not to do that. Okay, so the key here is this on-target perception updated. So this event, this delegate, fires every time the AI perception system finds a new target. So the way I'm doing this right now, and this is why I remember I was talking about how the spectator gets targeted. That's why, because what it does is the sensed actor, it just checks if it's a pawn and if it's player controlled, which the spectator is a pawn and it is player controlled, so that's true. So all of this stuff happens. But so in gameplay that won't be a problem. It's just a little weird thing for me right now in development. But so in gameplay this works great. This prevents the guards from like attacking each other, right? Because if they just checked any pawn, then they would just attack each other. So they make sure it's player controlled. If it's false, just nothing happens. But if it's true, then they set this sensed actor variable to be the actor that was sensed. Okay, so now we've got a reference to the sensed actor. Next up, I'm setting this variable has target to whether or not successfully sensed was true. This is part of the AI stimulus structure that we get off of here. And so basically, if successfully sensed was false, then we'll clear our sensed actor, and we will set our last seen location blackboard variable to be the position that the stimulus was sensed from. So this becomes useful in our behavior tree later on. And then we also clear our target actor, set our state, and update our state, which I'll explain these in a bit in a second. And yeah, 1 second, I gotta just run and do something. All right. So that's what happens if it does not successfully sense the player. So like if he's behind a wall or something. Okay, but if it's true, then we do, the opposite. We set our value, our blackboard target, to be our sensed actor, so that's going to be the player's pawn. And then we set our AI controller's focus to the same sensed actor. So this is the same thing, I just have to keep the wires clean. Now this node, the AI controller's focus, is responsible for setting the AI's rotation, so they'll actually track after you. Hey, what's up, Dr. Override? Welcome to the stream. I'm going over my current AI setup and kind of trying to sort of highlight some of the pros and cons of how it is working, and we're going to try to think of ways to improve it. Alright, and so then this is the pretty important part. We've got this enumerator for their state, so currently they can be fighting, searching, or patrolling. And so we set it to fighting, and then we just call this update state. And this is what actually basically triggers their different behaviors. So I just have this switch on enum for the state. So if it goes to fighting, then we run the fighting behavior tree. And I don't need this print anymore, so I'm going to delete it. And then I trigger an event called notice on the actual pawn. And yeah, it looks like we don't need this anymore. Okay, so that is what they'll do if it's fighting. Otherwise, they have this searching behavior, which just prints out the word searching. And that's fine because their actual search behavior is all defined in the behavior tree. And then patrolling, currently they can't actually, once they notice you, they can't lose you. And I think I'll probably leave it that way, because it's not really a stealth game. I don't know, we'll think about that. But, so currently they just, they patrol until they see you. And so what their patrol looks like is they clear their focus so that they don't rotate towards, some undefined point. And then, clear all this stuff. This is just housekeeping, and run their patrol behavior tree. Print out patrolling, and I don't need that anymore. So all we really care about right now, the most important thing is this fighting, which is run behavior tree, and we have a variable, so each guard can have a different behavior tree, or each subclass of enemy can have a different behavior tree. And that is a variable defined on our enemy base here. So it's in here somewhere. Yeah, combat tree. And that's this, enemy combat. Okay, so this gets confusing because it's like all these kind of like interweaving responsibilities. But that's why it's nice to keep this pretty simple. Basically, the way this works, so ignore this for now. Basically, what this does is if our target actor is set, then we move to the target actor. So if this condition fails, then it'll run this. Move to last seen location, and then wait. So that makes the guards just kind of chase you when they see you, and if they don't see you, then they'll go to the last point they saw you at, which works pretty well. We should test the AI changes in the arted test map. Yeah, that's a good idea. Okay, we can do that. Hey, what's up, Otten? How's it going? Welcome to the stream. We're just going over our current AI, and we're hopefully going to improve it and not break anything and not make anything worse. Life goals. Okay, so that is, where was I? That's basically, so that's kind of their basic, like, acquire and pursue the player functionality. So, That's pretty big. I can maybe kind of demonstrate how that works if I open up the AI debugger. So yeah, so see, he sees me and he's chasing me. And if he loses me, yep, see, he just plotted a course to the last scene point. And so, okay, so something we can do to improve that is, because when they get to that point, they just kind of stop right on the corner, which, you know, looks pretty stupid. So what would be better would be to use EQS, so he's going to the last point he saw me at, right? And when he gets there, he still can't see me, so he's gonna wait. And if you see on the behavior tree, it says wait, and he waits a random amount of time. And then when that's done, since they don't really have any more behavior, there we go. If I hadn't popped around to show myself, he probably would have just kept waiting there. So we could work on that, add a little more like kind of search behavior. But yeah, so for now, this is kind of pretty bare bones, but you know, it's working. So that's their sort of search and pursue. Now I'd like to talk about their actual like attacking mechanics. So catch up on the chat here. Auten working on some input setting menu right now. Nice. Yeah, that's classic. Every game needs that. Imsim Cook, this is so exciting. Heck yeah. Yeah, it's pretty exciting. Oh yeah, okay, let me, Harrison wants me to show off his new level. I guess we can do that. And this is all still very much in progress, but yeah, Harrison's been working on this quite a bit, and I think it's getting pretty cool. So yeah, let me swap to my first person, and let this cook up a little bit. Okay, feels pretty good. So yeah, here we go. This guy's like blind. Is he gonna notice me? What's this guy doing? There we go, now he sees me. Oh yeah, and they have that little roll, so I'll explain how that works too. It's pretty simple. But yeah, this is what I want to fix. I want to fix this like clumping up. Yeah, I don't like that, how they clump up. But yeah, there we go. So yeah, if I run away, they'll chase. And if I get around a corner, then they should chase. Yeah, there we go. So yeah, I want to fix that too. So I want to fix when they get to the corner, they just sort of stand there. I'd rather them utilize the EQS system to like pick a spot kind of near it and sort of fan out. So hopefully we can do that. My gosh, Deadlock has arrived. So true. Anyone got some thoughts about the recent 20th anniversary archives? Oh, you're talking about the Half-Life documentary? I regret to ashamedly say I haven't watched it yet, but it's in my like watch list. Mild one, yeah, them shooting each other is a bit of a nuisance. I don't know, could be fun. Could be fun to have some team killing action. All right, so yeah, let me talk about their actual like attacking. So I'm trying to lay this out in a nice like modular way so that this can all be kind of figured out. Why do they glow? Why do they glow? Yeah, because cool. Yeah, Harrison's got it because it's cool. And that's just the vibe. Yeah. All right. Sorry. So I've got this broken down into components, and let me talk about the aim component first. So this is our, this is basically what actually controls them actually aiming and firing projectiles at you. So this is just setup stuff, just caching variables that we need. And then, right, this is one of these things I need to change because I'm doing it on tick, which is bad. Don't do anything you don't have to on tick, but I'm doing it on tick just for, you know, prototyping purposes. I'll performance optimize it later. Okay, do you remember that allow attack variable we mentioned back here in the AI controller? We set it here, or wait, no, sorry, this is a little bit of a web. We set has target in the AI controller, and then, oh yeah, here's some more stuff we're doing on tick, bad. But yeah, so this allow attack is set, so this is important though. It shouldn't be happening on tick, but it does all need to happen. So what we're doing is we're just using some really messy Boolean stuff. So what we're saying is if has target is true and is flinching is not true, and I'll talk about is flinching in a minute, and miscellaneous disallow attack is not true, and either can attack while falling or we are not falling, as long as one of those is true. If all of that is true, then we set allow attack to be true. And then in our aim component, we only move on if allow attack is true. So basically they're always trying to attack, but they're not always allowed to attack. And so that saves, that fixes things like when they're falling, when they spawn in, they fall and they hit the ground and they play a little like get up animation. Without that, they would just be shooting at the floor every frame that, they're trying to stand up, so we don't want that. We also don't want them to be able to attack while flinching, otherwise they'll be like, taking damage and flinching and just like firing wildly. So we don't want that. And yeah, we don't want, there's some other reasons. I have this miscellaneous disallow attack that I can set. So yeah, all this is just sort of like flow control to make sure they only are attacking when they should be attacking. Okay, so when that's true, then we move on to actually implementing all of our attacking logic. And yeah, let me check back on the chat, see if there's any questions. A solid skincare regimen, that's why the guards glow. So true, so true. Imson Cook, why stay away from on tick? Costly? Yeah, costly. So tick runs every frame. So it's kind of like in Unity, it's equivalent to the I forget what it's called. Update. It's equivalent to the update function. And so yeah, every frame your game is running, tick runs. So that means your game is running 60 frames per second. It runs 60 times in 1 second. So yeah, it's a waste of resources for things. So what I do in McSpace Biff, which is a little better, is I just have a delegate event that runs like with a delay, and then it just kind of cycles through, and so it runs basically like once per second, which is totally fine for like acquiring a target or something like that. Yeah. Welcome Tito's Vodka. What's up? Welcome to the stream. Yeah, okay, so that's why we don't like tick, but right, so since I'm still working out like my whole architecture for how the guards and the AI works at all, it doesn't make any sense for me to optimize it yet because I might change all of this. So I don't want to put a lot of effort into optimizing it and making it perfect because my entire premise might be flawed, right? So I want to make sure what I'm doing here works for the game, and then when I'm sure of that, then I'll optimize it. All right, so now we're almost through this brief review. Let me delete some of this stuff. Okay, and this is where it starts to get really like duct taped together, but I think it'll still be kind of fun. So what we do now is, so basically what we've done is we've said, okay, our allow attack is true, so we're going to try to attack. And so what we do is we check our enemy base and see if it get the sensed actor from enemy base. So this is the pawn, all right? So the controller possesses the pawn, or no, sorry. This is a component that's part of the pawn. So this is a reference to our owner. Yeah, so since this is a component, the component has an owner. It checks its owner to make sure it's an enemy base. If it is, then we cache that. So this is just a reference to the owning blueprint pawn that is the guard, right? So this is where his mesh is, this is where all his, logic is stored. And so our component is just accessing him and checking his sensed actor to see if we, sensed it successfully. Because we don't want to attack if we don't have an actual target. So if it's true, then we have this delay, random float in range, so that just means he's going to delay anywhere between 0 seconds and whatever this variable is, so it's 0.5 seconds right now. And the reason for that is just because otherwise they'll all attack you at the exact same time, which looks really silly when they're like all lined up and then they all, all fire at the same time. So this just adds a little delay so they don't do that. And then we get into the real nitty gritty, which is we call this function called animate aim. And so remember, I was talking about how like functional, like actual like things, like animations, they're all kind of controlled by the pawn itself. So this is a function of the enemy base class that we are now calling, and so we can jump there and look at how this works. And this is an absolute mess, but it's working for our purposes so far. Sometimes it's best to set up input settings before you get too far into the weeds. Sounds like you've got it figured out. Yeah, talking to Autumn. Optimizing before you're done is slow dev, like baking the lighting and everything, and then you make a level change. Yeah. Cough, us. So true. Yes. Yep, any of you who can learn from all the stupid stuff we've done in the past, that would be great. Okay, so yeah, a little jury-rigged. Attack timing and blend space is driven by this timeline, which is hilarious, and you shouldn't do this, and I'm not gonna do this. Don't worry, I promise I'll make this better before we ship the game, but oof, yeah, this is probably the worst part of this whole setup. So here's what we have. So animate aim fires, and it goes through a do once, and then we call this timeline, which is, it's a timeline. So it starts at 0, and then as, it goes up less than 2 seconds, it animates up over 2, and then it goes back down. What do we use this for, you might be asking? Well, so this is used for 2 things. It is used for blending between poses in the animation blueprint, which I won't go into too much, but basically you can blend, so it blends between his aim pose and his run pose over time, so that he goes from running to aiming, right? And then just because, we're just being messy, I have it set so that if this is more than 2, if aim is more than 2, then we go ahead and we call our attack function. So again, silly, very silly way to do this, but it's okay. It's okay for right now. And then after the attack, so this is responsible for actually like firing the projectile. When that's done, we go in, and this is just getting the animation instance and checking to see if it's a guard, pistol guard, or a shotgun guard, because they have different animation blueprints, because they have different sets of animations. So then we're just setting this aim variable, which blends them. Oh yeah, and then if it's neither of these, we just attack anyway, because if it's neither of these, it's probably a drone, and the drones need to attack too. So that's how all that works. Then attack. This is just another event. We used to have that. We don't need that anymore. But so the way this works is we get our sensed actor, which this is just a little helper class to just be like, hey, is the thing that we're sensing valid? And if it is, then we want to, go ahead and attack. So we do that, and we call the attack function of the weapon itself, which has its whole own string of logic. What do y'all think? Do you want to hear about that? Or is this enough? This is kind of a lot of information. The more I'm going through this, the more I'm realizing it's pretty complicated. I mean, it's all simple, but it's like a lot of simple things all kind of strung together. Do you make games for fun or money or experience? Yes, all of the above. started out for fun, and then eventually you start to make some money. Hopefully. A little bit brain hurty. Yeah. Keep going. Oh, great. Okay. So basically, this is our weapon, and this every enemy has its own weapon, and every weapon derives from the same base class. So far we've been in these just these 3 base classes, with the exception of the aim component, which is a component attached to this one base class. But so now we got to open up the weapon base class, and so this is, this is the weapon that the guards use, or actually the drones use it too. It's just the drone has an invisible gun, which is hilarious. But yeah, so attack. Basically, the way this works is we check the weapon mesh for its muzzle socket. So every weapon has a socket to tell where the muzzle is. And then we're just going to get that location and rotation. And so this logic, basically what this is all doing is it's getting the angle from the muzzle of the gun to the target, right? Because we've got our sensed actor that gets passed in as an argument, so we get its location, find the look at rotation. So that's the angle between the muzzle of the gun and the target. Okay, so that's a rotator. Now, if we just passed this in, so then the next thing is we just spawn our enemy projectile, which is this guy, right? This I don't know what's up with this weird viewport glitch, but it's the laser projectile. And maybe in a separate video I'll talk about this material because it's pretty interesting. But so for now, and I did make that. That's not a stock asset. I made that from some old stuff we had in Unity. I repurposed it. Okay, but so we spawn that, and at the location of the muzzle, and then we get the rotation. So if we just pumped in the rotation from the aim node directly, then they would always be able to hit you, even if they're off to the side. Thanks for stopping in, Shiloh. See you later. So what I wanted, because I wanted them, because okay, so the thing about having the projectile come from the muzzle is then it's subject to animation, right? So if they're animating in such a way that their hand is off to the side and they try to fire, then it's just going to go straight out. It's not going to go towards where they're actually aiming. So I wanted to be able to I wanted them to be able to actually hit you, even if their animation is in the middle of doing something kind of weird. But I didn't want them to be able to hit you, even if they're animating if they manage to get a shot off while flinching or something. I don't want the projectile to come out at a totally unrealistic angle. So all this logic is basically to add to clamp the amount of offset. So we've got a variable called aim adjust threshold, and so this is degrees. So basically what this does is it rotates the firing point within 10 degrees pitch or yaw to be able to actually aim to the player. So what that means is if they're if they're aiming off 5 degrees, they'll still hit you. But if they're aiming 90 degrees off, then they'll shoot 80 degrees off, which feels pretty good. I think it's a pretty good balance. Yeah. Oh yeah, and then the last thing that's pretty interesting is the projectile. So the projectile is just a simple, it's got the default projectile movement component, and it has some homing. So that means it'll actually follow the player. But the problem with that is if you dodge it, it'll just constantly circle you until it hits you. So there is some logic in the projectile itself. So it sets itself up, and then after a delay of homing duration, which is defined by the gun stats data structure that, whatever weapon fired this thing is passing it when that duration is up, it disables the homing. So that's really cool because it makes it so that basically if you're kind of like dodging, it'll sort of track after you for a short amount of time. But then once that amount of time has passed, it'll just fly straight. So makes it feel pretty dynamic. I think I'm pretty happy with how that turned out. Yeah, and so then we have a delay, which is based on our fire rate, which again comes from our gun stats data asset. So when that fire rate elapses, then we go all the way back and we reset our do once. So the way this works is basically the enemy is constantly calling this event, but it's only able to actually get through the do once after that duration elapses. So that way we can have, a guard with a pistol can, fire shots off really fast, but a guard with a shotgun might need to take longer. Yes, Mild One says they feel similar to the needler tracking in Halo. Yeah, that's pretty good. Pretty close to that. Or a charged plasma pistol shot, maybe. Cool. Alright, that's pretty much it. That's pretty much... oh, there's one more thing, actually. I've got this evasion component. And this is fun. The way this works is basically just every so often... so I've got variables for roll chance frequency, and crouch chance frequency. Oh yeah, and I have the crouching disabled right now because their crouch animations are totally wonky. But basically every so often, we just, get a random bool, and if it's true, then we roll, which is it just plays a montage, an animation montage of them rolling, so that's how they do that. And so you can make them roll more or less by just dialing in this random roll chance frequency. So basically every 10 seconds, they might just roll, which, feels pretty cool when they do it. It's like, whoa, that guy's serious. He just rolled. So yeah, with all that said, let's just take a look at these guys again. So there we go. He's running at me, firing, boom. Oh, see, that guy just hit something he shouldn't have. But yeah, see that he just rolled. So yeah, every 10 seconds they have a chance to roll. And so we may want to turn that variable up because it looks kind of silly when they're all just rolling all the time. Oh yeah, and there's a little bit of a random delay, I think, in there somewhere, so they don't all just go rolling at the same time, which would look pretty funny too. But yeah, so there we go. And I don't know if you can tell if the projectiles are tracking me, but they do kind of curve to catch me a little bit, which feels pretty cool. So that's where we're at. Sweet. Thanks for hanging in there. Get a sip of water real quick. Yeah, so I think next up we'll try to refine their positioning with EQS. That's a good idea. Mild One suggests we could do something where if they've been hit recently, their chance of rolling increases. Yeah, that's a good idea. Alright. So let's see here. Oh yeah, so I do have this little, bit of logic. I've made a custom decorator that checks if an enemy is near another enemy. And when that is true, it runs an EQS query to basically just find a point that's somewhere else. And so they kind of run away from each other. The problem is they all do it, and so they kind of end up trying to get away from each other, but then they're both moving at the same time, so it's like they're kind of like it's kind of like when you're like walking past somebody and you both kind of are like sidestepping. They kind of do that. Let me see if I can get them to do it. So yeah, see, you see how they did that? Basically, when he got close, the other guy ran off to the side, and now they're doing it again. So they're both like, hey, you're in my space. So they're both backing up. So it kind of, it's a little self-defeating. And yeah, they all kind of end up doing the same thing. So we need to kind of rethink that. One thing that I think I want to do first is fix this move to target actor. And so let's see, this will be easier if I only have like one enemy to deal with. So let me just delete everyone but that guy. Don't worry, Harrison, I won't submit these changes. Okay, so let me show you how to set up an EQS query. So we've got this thing. Okay, I've got my AI folder here, and so I've got an EQS testing pawn. And this is interesting because you can give it a query template. So here's my enemy spread out template. Oh yeah, and to make this doesn't come in by default. So the way this works is you just create a new blueprint class and derive it from EQS testing pawn, and then there's mine. So yeah, you just create it, and it's literally just for the purpose of visualizing EQS queries. Catch up on these. Oh yeah, for that we need a cover system. Alpha and beta. Oh, okay, so you're having idea. Yeah. So yeah, Mild One is thinking through different ways we could solve some of these AI problems. Yeah, I'm gonna think about that later though. I'm just gonna focus on making this guy find a better way to find you when he gets to the corner. So this is the problem I'm gonna focus on right now. So basically right now when he loses sight of me, he'll come right to the corner. And I don't like that. I want him to end up like there. So I'm going to make a new EQS query. Okay, so we do that. We just go in here and say environment query. Call this EQ. Oh, this might actually be tougher than I was thinking. Because I need them to kind of know which side to spread out on. For which I'll need a custom context and do some math. Let me think. That might be too much to do on stream. What might work better would be helping them find some place that has cover. Yeah, let's try that. Let's give that a try. Okay. So yeah, maybe we can give them a way to figure out like a good spot that has no line of sight to the player. All right, so set our new EQ cover to our query template, and now let's start working on this. Okay, so this has generators. All these different kinds of generators. Let's say generate grid around querier. So see, it makes all these points. So this EQS testing pawn is representing, an enemy making this query. And so we can change these variables. So grid half size is 500, space between is 100. The more points, the heavier it'll be on performance. So let's maybe give it 1,000. Because basically I want him to be able to figure out like the best place for cover. Yeah, I think we can use EQS to kind of procedurally have them find cover. I hope so anyway. Alright, so we can add all these tests to basically score these points. Pathfinder, what's this one? Okay, so this one basically finds out if it's reachable, which they're all going to be reachable. And you can make custom ones of these in C++, but not in Blueprint yet, from my understanding. So, distance to querier. So this way, what this is doing is it's basically saying it's trying to find the closest one. So higher numbers are a better score. I don't know if you can read this on the stream, but so this one says 1, this one says 0.01, and all the ones in between have a number in between. I can crank this up. And you see, so it's basically, he's trying to find, basically it's putting preference to the points that are furthest away. So basically this will tell it like, hey, whichever one of these points is the furthest, that's the one that I want. So he would go there. And so I could use this for like, if a guard, gets close to the player or the player gets close, he could use this to kind of retreat. I need to do more research on this stuff. Basically, I've done this before, but basically there's a way to get like the player's location fed in here. And so then you can figure out, like, you can make him go, like, towards or away. So yeah, like all these dot between two contexts. I wonder if these work. AI last perceived. Interesting. Yeah, there's definitely a lot of power here. It's definitely what we want to get this working. Yeah, we want them to be able to figure out how to get to cover. And so yeah, we could do that with a custom query to be like, this point is near cover, but we also need, it's not just enough for that, they need to be able to figure out if the cover is between them and the player or not, right? Because if you've got the player here, and they're like, ooh, there's cover here, so this is the closest point to the cover. That's not good, right? Because they need to get, this one, the one that's behind the cover. So, yeah, I need to look some of this stuff up. Because I need to get these contexts in here. Let's see, what can I tweak in the meantime? Or maybe improve near teammate. This works pretty good because it just makes them spread out, but we need to figure out if, well, that could be pretty easy. Let's do this. Let's take this and let's try to fix that little race condition they have where they kind of like, go toward each other, or they both try to dodge each other at the same time. Yeah, okay, so we can do this. Since we're getting a reference to our enemy base, we can add a variable to it. This is kind of hacky, but I think it'll work. Let's just say B for Boolean is repositioning. And what we can do is check that. Get is repositioning. And if it is true, if we are repositioning, then we need to set is repositioning to true, and then return true. So then we'll start the reposition. No, this needs to be a false, actually. Or wait, no, hang on. Because this is the other enemy. So if he's repositioning, oh yeah, hang on, this is confusing. I need this. Because I need a reference to ourself, because we're dealing with two instances of the same class here. So what I'm doing here is I'm checking if our AI behavior tree is running on an instance of enemy base, which it is. So, or it will be in this case anyway, but that's not guaranteed. So if it's not, I want to log a message about it. Then we're getting a reference to ourself, our BP enemy base. Perfect. All right, now we're checking our other enemy. So this is the one that we just kind of like got into his personal space, and so we want to check, is he currently repositioning? And as long as he is not, then we want to reposition. Yeah, so we set is repositioning to true on ourselves. But if he is repositioning, then I want to return false to the behavior tree. So this will make the branch of the behavior tree that is under this decorator only execute if we are overlapping another guard who is not currently repositioning. And then once we start, we will set ourselves to be repositioning. Cool. I need some way to unset that, though. What is a good way to do that? Basically, this will work the first time, I think. But I think it'll stop working after everyone has had a chance to reposition once. Then they'll constantly always be repositioning, and so they'll stop doing it. But let's see. Well, it won't work with just one, will it? So let's see if this works. Oh, having a little freeze. Hopefully the stream is still going. Alright. Since these guys don't have hearing, they only know I'm here if they see me. Alright, got one. Hey buddy. Okay, got him too. Alright, so yeah, they just spread out. It's saying reposition up there in the left. Okay, cool. That actually looks like it's working. So yeah, once he is getting into his space, he's backing up so that they aren't next to each other. But since he's got repositioning is true, this guy, I don't think... It's like he'll, so he'll always avoid him. Yeah. Well, that's kind of interesting. So that works as long as there's only two of them. I wonder if it'll work if there's more than two of them. It would definitely work if there were some way to clear out that reposition flag. I'm just trying to think when the best time to do that would be. So basically what's happening is this decorator returns true when those conditions are met, and so it makes him, run this EQS, which just gets a new point, and then he just moves to it and waits a little bit. Well, you know what I could do? I could just add a little decorator. I could just add a blueprint, not a decorator, sorry. A blueprint, a behavior tree task to reset it. Yeah, let me do that. That's not too bad. And those of you that are interested will kind of get a little crash course on how to make custom behavior tree tasks. So you just get BT task, blueprint base, and I think once I finish this, I'm gonna hop off because it's been just a short little stream to get back into it. So BTT, clear reposition flag. So the way you do that, once you make that, you get this blank event graph, but you don't implement any logic in the event graph. You override the function receive execute AI. And that gives you references to the owner controller and the controlled pawn. So get the controlled pawn and check to see if it's an enemy base. And if it is, we just set, what did I call it? Is repositioning, just set it to false. And then you have to call finish execute. And with success. And if our cast fails, we'll just return failure. Our cast won't fail, because this is designed to work with this particular class. And that's just kind of like a, restriction I have in mind. So yeah, that should work. And then just in our behavior tree, when this is done, when he's done waiting there, we just call our clear reposition flag behavior tree task. And now I should be able to have a bunch of these guys. And in fact, they could spawn right next to each other, and they should just, once the game starts, they should just spread out. Catch up on the chat here. Imsim Cook, I don't mean to complicate things further, but could be cool to have rolling for cover, entrance, and exit. Oh yeah, that'd be sweet. A cover dive versus a cover rollout. Yeah, that'd be sweet. And yeah, we need more animations for that kind of stuff. Alright, so if this all worked, they should not clump up anymore. It's a mad scramble to not clump up. That guy doesn't actually see me, so he's actually just patrolling to random points. But there we go, now he sees me. Hey, look at that. Ah. Never mind. They are trying to get out of the way, so they at least are only there for a minute. It's kind of working. Ish. Interesting. It's like, they all really want to be in the same spot, because, there's like kind of like a best spot to attack from. So they all really want to be there. And then that, like, evading, track on the behavior tree only runs so often. Well, and in fact, it's because I have this wait here. I mean, what if I took that out? I think if I took that out, they'll just, like, kind of be constantly shuffling around each other. Everybody see me? Yeah, look at that. They're just like, get away from me. They still kind of tend to get like pushed into a corner. They're close. Hacker support group. Okay, well, that's not working. Why? Maybe I need to make this bigger. 300 centimeters is not that much room. You know, part of the problem is probably just because there's so many of them. It's like they just can't, like the conditions are not really possible to meet. You know, if there were only two, they stay out of each other's way pretty well. Well, he's not even chasing. Come back. What the problem could be. I'll go. Oh, here it is. It's working less than it was before. I think we made this AI worse. Oh, he just did it. What the heck? I don't know, guys. I thought that would work. Oh well. Maybe a better format for this stream will be for me to just do all of this offline and then summarize it for you. Just do one stream every so many months. Worse or different? Definitely different. Or, I don't know. Yeah, a little worse. A little worse, a little different. Regardless, I better get going. I got some other stuff to take care of. Yeah, was that fun? Hope that was fun. Any questions? Our quarterly stream. Yep. Yeah, any questions or comments before I sign off? Imsim Cook, how have you been working on your game at all? You should, if so, you should share it in our group. Super fun. Yeah, definitely super fun to be back. We'll keep these going. all about getting into the nitty gritty. You come to the right place then. Nice, nice. Cool. Well, for anyone who's just now finding this, anyone who's just now joining or, just discovered this stream, we're Skunk Ape Interactive, a two-man dev team, just kind of trying to make some cool games. We've got a handful of them. They've been playing down there in the corner. And yeah, we're kind of working on a VR game now. We've got a couple of desktop games. And yeah, we're just kind of trying to, build some cool stuff. Wub says, genuinely thought you ditched YouTube to stream on Twitch instead. No, we're on both. Hopefully we're on both. Hopefully it's live on both. Oh yeah, because we've been gone for so long. Yeah, it's just been busy. It's just been hard to find the time. Me and Harrison both work, full time. Harrison's got a 9 to 5 and I've got a 24/7, so it's been tough to find the time, but made some today, so hopefully we can make some moving forward. And then a lot of the Deadlock stuff is rough because it's like we're laying the groundwork, so like all this stuff I just walked you through has been, the product of, quite a few weeks. Harrison's not quite an 8-9, not quite a 9 to 5, more like an 8 to 7. Yeah, that's rough. But yeah, we're going. So yeah, make sure if you want more updates, join our Discord. We kind of post in there. Harrison's better about it than I am. I'm always there though. I'm lurking sometimes. But yeah, sweet. So that's us. Harrison has a stream that he does here on the same channel. With also decreasing regularity, hopefully soon to change. And yeah, we've been a little better about posting in Discord, so that's the place to find us. And then keep an eye out. We're getting, as this demo shapes up, we're really hoping to have at least like footage of gameplay like before Christmas, and then we can start getting our Steam page kind of back online and alive again. I just set up the build pipeline for getting our Unreal builds to Steam, so if any of you have VR, we're going to be looking for VR testers, so hit us up and we'll get you onboarded for that if you're interested. Yeah, man. Come back, I need the stream. Okay, we'll come back. We're back. Just for if just one person benefits from the stream, then we'll stream. The need to stream. Alright. Signature 10-minute outro. Thanks for hanging out, guys. I'll see you later.